Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
So node 200, which is the current node, is the master, and other nodes are just no special rules. So they are worker machines. Now, our node says not ready. Our status of the nodes says not ready because one component of the entire cluster is missing. Right, one component of the entire cluster is missing, which is actually the networking part. Right. So now all the components can talk to each other, but there is one thing that is missing, which is the container networking interface. Okay, so what does that mean? Well, in Kubernetes, each pod gets its own IP address. Each pod gets its own IP address. Okay, and right now we have no component installed which can grant this IP address to our pods. So we need to install a networking interface to which the pods can attach to and get their IP addresses. Okay, so for that, well, if you go back to the documentation here, uh, 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 here you see it says install a pod network add-on. You must deploy a container network interface base pod network so that your pods can communicate with each other. Okay, so we have to install it. Now there are many networking solutions available, right? We can go to here, that the solutions which help us in achieving this, and here you can see the list of all the solutions. If I scroll up, actually this is the networking page, and here on the right hand side you can see a high level overview of which are the networking solutions that you can use. Again, based on experience and based on your research, you can choose whichever you want. So there is ACI, which is mostly for Cisco clients. Then AWS VPC is used by AWS generally. Azure is used by Azure. GCE used by GCE. And there are some open networking solutions as well. So Flannel is an open networking solution. Then Contiv is an open networking solution. Calico is an open networking solution. Then you have ViewNet. Okay, so I generally use Calico. Right, so I will have to install Calico networking or any of these, whichever you like, whichever you have a preference. I'll go with Calico. So how do I install Calico? Well, I have to find the documentation by Calico themselves. There is no straightforward documentation on Kubernetes website. So I'll go to Calico. There's a small introductory paragraph here, and one of the link will take me to the Calico website. And let me look for documentation here. It says blah 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 blah. Let's go to install Calico. And for Kubernetes, yes. And okay, it says, do you want to install on EKS or GKE or OpenShift or where? Well, I have a self-managed on-premise cluster because we are having a self-managed cluster. I'll do this and I'll say install Calico for on-premise deployments. And this is the documentation that I get, right? And yeah, this is the command that I need to run. kubectl apply calico.yaml. So I'm expected to download the calico.yaml, and then apply it. Okay, what it will do, it's not of very important high importance here that we know what apply does. We will come to know about it later, but for now I'm going to apply this calico.yaml, right? So I can straight away give this URL and apply it in Kubernetes. I'm going to connect to my master here, and I'll say kubectl apply -f. I did not copy it, I guess. Control C, and the URL. Now it is going to create a lot of resources on the cluster, and in a minute, hopefully, you will see that cluster nodes will be ready. Okay, we go back here.
I mean, like when you're like when you're applying the Calico YAML, are the resources like when it's implementing the resources, is the YAML a set of instructions, or is it pulling like resources from the like additional resources from the internet when you apply it?
Yeah, we'll come to that. As I said, I will discuss about what it is doing here because we are not prepared to understand that yet.
Okay.
Yeah. Okay, so now I say kubectl get nodes, and what do I see? That all our nodes are ready because they found the network that was missing. Okay, our cluster is set up. So what did we do to install the cluster? Well, we did a lot of steps. First thing is to install, sorry.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Install Docker, then add Kubernetes repository for apt, and then install kubeadm, kubectl, kubelet, kubeadm, ttl, kubelet. Then we did a kubeadm init, which initialized our cluster. Then this was not enough because we need to install the network. But before that, we copied over our kubeconfig file, right? And then we joined our nodes. For both these activities, a command is generated. We don't have to do much. And then we install the network. So install Calico, and that's all.
Jessica, could you just repeat what does kubeconfig like in the 7-step process? What does kubeconfig contain?
So to talk to API server, you need to authenticate, right? And you need to authenticate so that you can deploy the workloads or explore the cluster and see what is happening in the cluster. Now, to talk to API server, you need authentication, right? And by default, we have not created any users or any authentication mechanism. So this authentication is based on TLS certificates, right? Your SSL certificates. Now, when the cluster is bootstrapped, it creates its own certificates and keeps them in its own config file. Now we take that config file and use that for authentication via our kubectl client. So now whenever we will say kubectl some command, it's going to use this config file which we copied over and use that certificates and that authentication to authenticate to the API server.
Okay, that makes sense. That makes sense. And then, like you defined earlier, like, are you considering like workloads pods? Or
So workloads are, I mean, that's a very generic term. Workloads could be anything that is deployed on the cluster. Okay, so it could be pods. Generally, people also tend to use containers as workloads, but that's not actually managed by Kubernetes, as I explained. But pods or your deployments or daemon sets or
okay,
many things which are
okay,
deployed.
yeah,
Yeah,
it's a generic term. Okay,
yeah,
that
it's a
makes sense.
generic term. Yes. Okay, so maybe for better explanation, I will also show what is in the kubeconfig file. If you remember, we did this. Okay, where did it go? Conf. What? How can we lose that? Copy command. Yeah, here. So I copied this conf file, which was generated within Kubernetes, which contains the complete information about the cluster and the authentication to the cluster, and put it in my home directory. And then whenever I will run kubectl, it will look at this file and use it to reach out to the server and authenticate it. So if I have to see what is inside this file, well, this is what is inside the file. It has information about where the server is running. So IP address of the machine and port 6443. It has the certificate authority data. So how to sign the certificates, if or to how do I say, how to validate that this cluster is what it says, right? So how to set up the trust using SSL. Then it has the user information, how to connect to the cluster. The username is Kubernetes admin, and it has its own certificate and key. So it will use all this data to authenticate to my cluster. Okay, that's what is in Kubernetes. Oh, sorry, kubeconfig. Cluster is up. 3-node cluster is up. One is master, 2 are worker nodes. Any questions? No questions. All right. So now if we say kubectl get, well, kubectl is a client now which we can use to explore our cluster. Okay, and kubectl has lot of commands available for exploring the cluster. I will take you through some of them, right? For example, you can create workloads on your cluster by running this create command, right? Create, oh, please give me a sec, my charger is connected but it's not powered on. All right, so create is used to create a resource. Expose is to expose a resource. Run is to run a workload or run a pod. And then there are some exploratory commands like explain something or get details of some resources, or edit some resources, or delete some resources. Then we have deployment and all, which we will talk about later. Then we have some cluster management commands. I don't think we will have time to see those. Then we have some troubleshooting commands. We will talk about some of them. So if you want to describe a resource, see the logs of some pods or containers, do exec on some containers inside a pod, similar to Docker exec. Then similar to Docker CP, similar to Docker logs, we have these commands here. And then there are some diff and apply and things like that, right? So, well, kubectl is the kind of a Swiss knife to work with the cluster. Okay, so kubectl get is the command which will get you all the resources, right? It will get you all the resources that are available on your cluster. So if you just say get and the resource name, it will get you the details, right? So what are the resources that you can create on the cluster? So there are some workloads, and there are some configurations and other things that you can create on the cluster, right? So just to see a brief overview about how you can see all the resources on the cluster, you can say kubectl API resources.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Right, and when you press enter, what did I typed apt API resources, and it is going to show you what are the resources available that you can manage on the cluster. Right, I can maybe say name. Yeah, so these are the resources that you can manage on your cluster. So you have pods, right? You have pod templates, secrets, nodes, namespaces, deployments, replica sets, blah blah blah. Lot of things which you can manage on your cluster, right? So you can run a get command on any of these resources to see what is available on your cluster, right? So the first command that we saw was kubectl get nodes, and it'll show you what are the nodes running here, right? By default, it will show you minimal information. If you want more information, you can say -o wide, which is going to give you much more information about your resources. So we see that this is the node name, this is the status, this is the age of the node, this is the version, this is internal IP address of the node, then what is the OS running there, what is the kernel, and which is the container runtime. Yeah, so complete information about the nodes. Now, if you are running some pods, you can say kubectl get pods, and it's going to show you what are the pods running here. Now, unfortunately, we do not have any pods running here. Okay, I will also show you one more thing that you can do to make your life a little bit easier. Now, if you see, I'm typing all these commands by hand, and I need to remember everything here, right? For example, I need to remember that nodes will go like this, or if I say API resources, it has to come like this, right? Wouldn't it be nice if there would be some auto completion on kubectl commands, something similar to how Linux has? So if I type systemctl and if I press tab, it auto completes, and if I press tab again, it auto completes, right? Wouldn't it be nice to have something like this for all kubectl commands and subcommands? Well, you can set up that by running these two commands here like this. Now this is going to add kubectl completion to your bash shell. Now if I say kubectl, if I press GE, press tab, it auto completes, and if I say nod, press tab, it auto completes. Right, so I don't have to remember the complete names. I can just press tab and have auto completion. Okay, coming back to our discussion here, kubectl get nodes. It show me the nodes. Kubectl get pods will show me the pods. Unfortunately, the pods are not running here. Now in Kubernetes, you have a concept of namespace. Okay, I can run some pods on the Kubernetes cluster. There may be some other person who is accessing the same cluster. They can run their pods. There could be some other team who is using the same cluster. They can run their pods. Now, it will be stupid to let everyone run a pod in a common space without having any boundaries or any limitations. My pods can interact with your pods. I can delete some other person's pods. Some other person can modify my pods. So that should not be done. So in Kubernetes, you have something called as namespaces, which are secured zones in Kubernetes where you can run your own pods, right? So you can have namespace 1, namespace 2, for example. Maybe namespace 1 has certain users, namespace 2 is used by certain other users, and you can run your workloads there. You can create your pods there and other namespace specific resources there. So namespace 1 users who have access to namespace 1 should not be able to access namespace 2 resources. Users who have access to namespace 2 should not be able to access namespace 1 resources, right? So namespaces are important. Now Kubernetes components, as I told you, when Kubernetes bootstraps itself, it runs API server, scheduler, and all that. Well, all that is also run as pod, as I mentioned before, and it is run in kube system namespace. And all my pods, which I will start, will run in a namespace called as default. Okay, so if I go to my cluster here and if I say kubectl get namespaces, I see that there are 4 namespaces already created. So these namespaces are created by default. There's a namespace called default. There's a namespace called node lease, public, and kube system. Now these 2 namespaces are not discussed here. I will not discuss them, but these 2 I will. So default and kube system I will. Right. So all my resources, if I do anything right now on the cluster, all my resources or workloads will be created in the default namespace, and all Kubernetes system level resources are created in kube system workspace. Right. If I say kubectl get pods, well, this command runs and shows me the pods in my namespace. That's why it says no resources found in default namespace. If I say kubectl get pods and namespace kube system, well, you will see a lot of pods are running in kube system namespace. And you will see some familiar names. You will see that etcd is running, API server, controller manager, proxy, scheduler, right? And some Calico related pods are running. And some DNS services are also running. Okay. Now API server, controller manager, well, let me have a wider output. So API server, controller manager, etcd, scheduler, these 4 components are running, all are running on node 200. Right? If I just say all these are running on node 200. etcd, API server, controller, scheduler. Right? These are the major components that we talked about.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Here, 1, 2, 3, 4. Now proxy has to run on each machine, each node. So you will also see that the proxy, there are 3 proxy pods also running, and each is running on different machines on 200, 171, and 161. Right? These are our machines. Sorry, here, these are the machines, nodes 200, 171, and 161. Right? So proxy is running on all of them. Now DNS server is also going to run on most of the machines here, and Calico and all. Calico will be running on all the machines also. Okay, so these all components together actually make up our cluster. All right, and all these pods are running in kube system namespace. You can create your own namespaces by just saying kubectl create. Now create is a command to create some resources. If I have auto completion installed here, and if I press double tap, it will also show me what are the options, what I can create by using create command. So I can create a deployment, I can create a job, cron job, or a namespace, right? So I can say create namespace and DevOps school. So namespace DevOps school will be created. I say kubectl get. Now instead of typing complete namespace here, I can also say ns. Kubectl get ns, and I see that DevOps school namespace is also created. Okay, now how do we run resources in this namespace? We will come to that later, but yeah. Okay, any questions up to here, up to now? All right, now let's create a pod. Let's run our application. Let's say an Nginx based application. kubectl run is a command to run an application. Okay, but generally, if you see as and when we proceed through our course, we will see that run is actually not the most used command here, but it's the first command that everyone should learn. Okay, kubectl run, and then this is going to create a pod, and in the pod it will run our containers. So kubectl run, let's give the pod a name. Let's say my first pod. Now this pod should be based on image Nginx, yeah, and there should be port 80 on which the application should be accessible, and that's all. It is similar to docker run command, right? Docker run container name and the image name and the port if you want to expose. Similar to that. Press enter. My first pod is created. kubectl get pods, and what do we see? My first pod. In the my first pod there is one container. Out of that, 0 is ready as of now, and the status of the pod is container creating. So that means inside the pod container is being created. Okay, let's get the pod again, and we see that this pod is now running. 1 out of 1 containers which are supposed to be inside the pod are up. kubectl get pods -o wide. Now this pod is running. It has its own IP address now. 192.168.150.129. It has its own IP address. It is running on node 171. Yeah. If I browse for application on this IP address, it gives me Nginx. So my Nginx application is running on this pod. Okay. Makes sense how we can run a pod? Now what do we do? What we can do with this pod now? Our application is up and running. We can check the details of this pod. So there is a command called describe. We can say kubectl describe pod, my first pod. So I want to describe this pod. Describe will give me detailed information about my pod. And here is the complete detailed information. So name of the pod is my first pod, namespace is default. This is the node on which it is running. This is the labels which we will come back to later. This is the IP address of the pod. And inside the pod, there are some containers. What I see here is there is only one container here, right? And this container is based on image Nginx. It exposes port 80 and here. Right now, there are also other configurations which, if time permits, we will see, but if it doesn't, then we won't be able to see. Yeah, and at the end you will see events. Right, what is events? Is the events list down all the activity that has happened on the pod since its beginning. So we see first the pod was scheduled by the default scheduler. So we have a scheduler, right? A scheduler. When we executed kubectl run command, the command was hit against the API server, right? And then API server said, okay, scheduler, schedule this pod. The request is coming in, schedule the pod. So scheduler scheduled the pod and assigned it to a particular node. So it says here, assigned this particular pod to this node, right? And then what scheduler actually does is it talks to the kubelet, right? Kubelet is our agent. So then kubelet takes over and it's now pulling that image nginx and then started the container and started the pod. Okay, and that's why our pod is running. If I want to run my pod here, and if I say namespace as DevOps school, then the pod will go and run in DevOps school namespace. By default, it uses my default namespace, but if I want, I can run it on any other namespace also. Okay, if I press enter, the pod is created. If I say kubectl get pods, well, this is the older pod here. How do I see the pod which is created in this namespace?
Thanks for watching. Want to study further? Join our training programs today.